Algebra 1, Lesson 105, we are looking at geometric sequences, being able to recognize them, extend them, and also create formulas for them. So a geometric sequence, what we are looking for is a constant ratio between the terms. So a common ratio is something like 3, 6, 12, 24, where we can see that from 3 to 6 we multiply by 2, 6 to 12 we multiply by 2, times 2, times 2, times 2. And if this is kind of hard to see, we can always do something like, we can say, well, if I take my second term, 6, and divide it by 3, that should be the same as doing 12 divided by 6, which is the same as 24 divided by 12. All of these equal our constant ratio of 2. Another example, we'll look at a few on this page. So on this next one, 4, 12, 36, 108, we could do 12 divided by 4, 36 divided by 12, 108 divided by 36. These end up all being the same as 3. So we would say our constant ratio is 3. Now, those are all ones that are growing. We're getting bigger numbers as we go along. We can get smaller ones as well, or alternate between negative and positive. So in this next one, I should have said negative 80 divided by 320 should be the same as 20 divided by negative 80, or negative 5 divided by 20. All of these end up being negative 1/4. Okay? And this next one, 0.4, 1, 2.5, 6.25, we can definitely divide here, or we could just see from 1 to 2.5, I would have had to multiply by 2.5, which seems consistent with the rest of them. So that is my constant ratio. Now, if we want to extend them, we have to know what the ratio is and then just continue working with that ratio. So like from 2 to 8 to 32 to 128, find the next 4 terms. Well, looks like we are multiplying by 4 here between. So I would say 128 times 4 would give me 512. All right, and then multiply by 4 again, and I get 2,048. Multiply by 4. We get 8,192, and last time multiplied by 4, we get 32,768. So just continue the pattern by using that constant ratio. Or maybe we're using something that's decaying, getting smaller. And in this case, it looks like we're dividing by 3, or we could say multiplying by 1/3. So if I take this 4/3 and multiply by 1/3, well, I get 4/9. Multiply by 1/3 again, I'll get 4/27. Multiply again, we'll get 4/81, and 4/243. So we can use that ratio to find the next terms. Now, we need to be able to write a rule for this so that we can find any term, not just the next 4, but maybe the 100th term. Okay, so look at our pattern for 2, 8, 32. So if I say term 1, well, that term is 2, which we could say, and I know it's a little bit funky, we could say it's 2 times 4 to the 0 power, since that's just 2 times 1. Now 8, we would have to say I take my 2 and multiply by 4, since that's my constant ratio, and I'm just going to show it as 2 times 4 to the 1st power. How to get 32? Well, that's 2 times 4 times 4, since we do it twice at this point, so 4 squared. And 128, it's 2 times 4 to the 3rd power. If you look at those exponents, what you'll notice is that each one of them, okay, if it's an exponent of 0, I have my first term. Or my second term gives me an exponent of 1, 3 has an exponent of 2, 4 has an exponent of 3. It's always 1 less than my term number, because my general form is always saying a sub n is equal to my first term, a sub 1, times my constant ratio to the n minus 1 power. Okay, we always say that it's to the last amount of numbers in that exponent, meaning if I have a term of 6, I would be going to the 5th power, which means for this rule, I would say 2 times 4 to the n minus 1 power, so that I can find any term that I want. So let's try it again. And just to make sure that we're clear on what all of these mean, so if I have a sub n, that equals my first term, a sub 1, and I'll put a little 1 here just to remember that it's a sub 1, times our ratio, r, to the n minus 1 term. Okay, that means the previous term. So if we have something where the first term is 7 and the ratio is negative 3, well, we could create a formula to say a sub n is equal to 7 times negative 3 to the n minus 1 power. The first term times the ratio to the n minus 1 power. And then I want to find the sixth term. That means that I want a sub 6. And wherever I see n, I now replace it with 6. So I say 7 times negative 3 to the 6 minus 1 power, which really means I'm doing a sub 6 is equal to 7 times negative 3 to the 5th power. Well, if I do negative 3 to the 5th power, let's see what I get. I am going to get 729, negative 729, and then I multiply that by 7, which I believe gives me a negative 5,103. Okay, so we can plug this into our calculators or do it by hand, whichever you are doing, to find that sixth term. Okay, and remember, we're going to do that exponent before we actually multiply by 7. Now a different one. What if the ratio was 1/2 and the first term was 32? So we would do a different formula here. A sub n is equal to the first term, 32, times 1/2, that's our ratio, to the n minus 1 power. So if I want the sixth term, a sub 6, I would be doing 32 times 1/2 to the 6 minus 1 power, or to the 5th power. Well, 1/2 to the 5th power is just 1/32, which means that I have an answer of just 1 here, and you can try that out. All right. Now, last few examples here, we're going to look at a couple of different ones. You can try these two on your own. If the first term is 1/8, then the ratio is 4. Find the 8th term. Find the 12th term in this sequence. So generate that formula by finding the ratio and then plugging in to find the 12th term. Let's try this one down here, negative 288, 48, negative 8. Well, if we look, it looks like our ratio is negative 1/6. Our first term, a sub 1, is negative 288, which means our formula is a sub n is equal to negative 288 times negative 1/6 to the n minus 1 power. And so if I want the 5th term, I'm going to do a sub 5 is equal to negative 288 times negative 1/6 to the 5 minus 1, which is 4th power. Well, if we do that, we end up seeing that this is negative 288 times 1/1296. That's what negative 1/6 to the 4th is. And if we do that, we end up simplifying a ton, and we get down to negative 2/9. All right, you can try this next one. You'll realize that the ratio is actually quite nice. It looks kind of nasty to begin with, but it is quite nice. All right. Now, looking at all of these different examples, we can relate them to real life because what we're really looking at is exponential growth or exponential decay. Now, whenever we see this, we are seeing that, okay, if I have something that's a small ratio, like a fractional ratio, I'm getting smaller and smaller and smaller. Okay? So, if I have a ratio under 1, I have exponential decay. Whereas if I have something like this where I'm growing and growing, hint, the ratio is 7, okay, I'm growing and that is exponential growth. So if a ratio is above 1, then I have exponential growth. Now, negative ratios are a little bit funny. As you can see, they go back and forth from positive to negative. But when we have just plain ratios, if it's under 1, it's decay. If over 1, it's growth. So if I look at this example, a ball is dropped from a height of 2 yards. The height of each bounce is 85% of the previous height. What is the height of the ball after 10 bounces? So what's the common ratio? I am taking 85% of each one previous, which means that's my ratio. But I'm going to put it as a decimal as 0.85. And what's my initial? Well, the first term is 2, which means I can plug it in and say a sub n is equal to 2 times 0.85 to the n minus 1 power. So that I can plug in 10 and figure out how high it is after 10 bounces. Okay, this is exponential decay. Because that number, that ratio is below 1, this is exponential decay. I'm getting smaller each time exponentially. All right, same thing here, okay? You can try this out on your own. It's 90% now. We're finding after 7 bounces. Once again, exponential decay. As you can imagine, that ball is not going to continue going higher and higher and higher after each bounce. We're getting smaller and smaller. Okay? So you can try this. I'll just leave a few more of these here for you to try and see how you do on these. Find that ratio, plug it in, and then plug in whichever term you are needing. Well, I hope this is helpful for your homework and for studying.